The next thing that we want to look at, the next item, is talking about intercepts. So we can describe a function by its intercepts, right? So when we look at intercepts, there's two different types of intercepts. There's an x-intercept and a y-intercept. Most of us, when we think of an intercept, we think about, well, it's an intercept because it crosses the axis. And graphically, yes, that's what we want to look for. So when we're looking at a graph, we want to look for where the function or where the relation crosses the axis, whether it be the x-axis or the y-axis, depending on which intercept they're looking for. So if I'm looking for the x-intercept, I'm going to find where this function or relation passes the x-axis, all of the places, because I could have more than one. And if I'm looking for the y-intercept, I'm going to look for where the function or relation crosses the y-axis. All right, I'm going to write it as an ordered pair. Okay. If I have an equation, then I'm going to evaluate, that's what we were just looking at in the last section. If we want to evaluate on an axis or on an intercept, that means we're going to plug in specifically 0. So they're not going to give me function notation and tell me the number to use. The keyword of intercept means that I need to be plugging in a 0. So if I'm looking for the x-intercept, I'm going to substitute a 0 in for y. I'm going to substitute a 0 into the opposite value that I'm looking for. If I'm looking for the y-intercept, I'll plug in the 0 for x. So let's look at some examples here. We're going to start off nice and easy with our graphs. So looking at the first graph, first off, hopefully we remember that this would only be a relation. This first graph is actually not a function. It's a relation because it would fail that vertical line test. But I can still find intercepts from a relation. Okay, so if I'm looking for my x-intercept or intercepts, I'm going to see where does this graph cross the x-axis, where it's going to cross two different places. It's going to cross at -4, and I'll make that an ordered pair. And then it's also going to cross at 4, again making that an ordered pair. Okay, then if I'm looking for the y-intercept, then I'm going to look where does the graph cross the y-axis. In this case, I'm going to have two values as well. I'm going to have the point at 3, so I'll make that an ordered pair 0, 3, and the point 0, -3. So let's look at the next example. Again, to find the x-intercepts, we're going to look at where does the graph cross or intersect the x-axis. So the first x-intercept that I'm going to see here is at the point -2, 0. And the next time it's going to cross or touch the x-axis is going to be at 2, 0. Right, so I'm going to have two x-intercepts. Now let's look for our y-intercept. So again, our y-intercept, we're looking for where does the graph cross or touch the y-axis. And I can see right up there, it's going to be at 0, 4. Right? Now, we can also find the x and the y-intercepts from an equation. Again, instead of looking at where they cross the x and the y-axis, we're going to evaluate at 0. So when we're finding the x-intercepts, we're going to evaluate x when y is 0. So we're going to plug in a 0 for our y and find x. So doing that in this first example, I would say 0 equals 3x minus 4. Remember, f of x is the same as saying y equals. So I'm going to plug in a 0 there. Now I'm going to solve this equation. So solving that equation, I'm going to add the 4 to the other side. And then I'm going to divide by 3. So I would get that my x-intercept is at 4/3. So my ordered pair would be 4/3, 0. All right. To get the y-intercept, I'm going to evaluate 0 again, but this time I'm going to evaluate plugging in 0 for the x value and finding the y. All right. So that's going to look like y equals 3 times 0 minus 4. See, this time I'm putting the 0 in for x. So I could simplify that down. 3 times 0 is 0. 0 minus 4 is negative 4. So y would equal negative 4. My y-intercept would then be 0, negative 4. So let's try one more example from an equation. Make sure we can do this. So to find the x-intercept, remember we said we're going to evaluate making the y 0. So that means I'm going to say 0 equals x squared plus 7x plus 12. Since this is a quadratic, I can either solve by the square root property, solve by the quadratic formula, or factor. This one for me is going to be easiest to factor. We'd say what multiplies to 12 and adds to 7. I'm going to get x plus 3 and x plus 4. So now that we've factored, remember to solve it, I'm going to set each factor equal to 0. So x plus 3 equals 0 and x plus 4 equals 0. Solving each one is going to give me that x is equal to negative 3 and x is equal to negative 4. All right, so I'm actually going to have two x-intercepts. I'm going to have an x-intercept at negative 3, 0, and I'm going to have another x-intercept at negative 4, 0. Okay, so the x-intercept, just like in the last one, I'm plugging in a 0 for the y, but this one had a little bit more solving to it only because the equation that I was using was a quadratic versus a linear equation. So it's not that finding the intercept is more difficult, it's the solving in finding the intercept that could be a little bit more cumbersome here. Right, so let's find our y-intercept. Our y-intercept we're going to evaluate again. We're going to evaluate plugging in 0 for x. Doing that, we're going to have y equals 0 squared plus 7 times 0 plus 12. So I'm going to simplify that. 0 squared is 0, 7 times 0 is 0, so y is going to equal 12. So I have one ordered pair, 0, 12, for our y-intercept. So I can find an x and a y-intercept by either finding it on an axis if I'm given a graph, or plugging in, evaluating at 0 in either the x or the y if I'm given an equation.